this course. Okay, so let's start with the concept of information retrieval. What is information retrieval? Please write on your paper information retrieval, whatever comes to your mind when you hear the word information retrieval. Pause this lecture and write. And when you are done, just resume the video. So if you can see, we have in this Venn diagram, we have two circles. This circle is the data circle, and this circle is the meaningful data circle. And also you can see main heading is circle is informatics circle and is the computer science circle. Information retrieval in simple, when you go to the Google, you type some information, you get some information. This process we call information retrieval. But this information retrieval process, which we'll see in a very simplified way, is not that simple. There are several tools and technology involved at the back end. When you type a keyword, just say you type the iPhone X and this keyword, and when you hit the word on go, so there are several steps which involves at the back end to find the related information for you. So we have some sort of database at the end. We have some algorithms, algos. We have some vocabularies and ontologies at back end, which help us and which helps the search engines, just like the Google search engines, to fetch the information for you. So from this slide, the things to remember, please write on your page. Information retrieval involves both computer science and informatics. Information retrieval involves both computer science and informatics, full stop. Then information retrieval is the process of fetching related information using search engine such as Google. Okay, now let's see that how does the search engine work. Search engine, we have the search engine Google, we have Yahoo and Bing. So these are the big search engines that we have available on internet. Now please stop this video and go to this link. When you will click on this link, you can type any word, or it will actually very interactive. They already have some keyword which will take you and will tell you the process how the search engine works. We will take an example of searching iPhone X. Okay, then how the search process work? Let me find some empty space. Okay, we can just clean it here and use it. Now you type the word iPhone X and in your Google, and here is the go button. Now the Google search engines, they have the large database at the back end. Large database at back end, right? Consider a library example, then it will give you a sense. So in the library, when you go to the library, okay, so this is the library building. right? So you enter to the library and you ask to the librarian that you are looking for a book on, uh, say, metaphysics, physics. Okay, you give a title, or you give a title to a book, right? So now the librarian knows that this book belongs to some science category. So the librarian will tell you, or librarian will lead you to a different, maybe a bookshelves, and they will write, they will take you to the science portion, not the literature portion, or there are different portions: science portion, literature portion. Then you have the portion about something just like the portion about the philosophy. But on the science portion, then there will be a further distribution, and distribution about the chemistry books, physics book, and then in the physics book there will be again solid state physics, astronomy, and then there will be a metaphysics. And over there on some shelf, uh, you will find your book. Similar to that, like physical library, consider this is a library, but here things are stored electronically. We have different databases, like database about food, right? Database about food, database about hardware database, and multiple databases, maybe thousands or millions of the databases at the back end. So we represent it with the infinity layer. There are several databases. Now, when you type the iPhone X, hit on the go, there is an algorithm working at backend. So we, with a gear sign, we can say this is an algorithm, computer algorithm. Computer algorithm is an intelligent program which takes the input and will search uh, for the related contents from the databases. Now, iPhone X, your Google search engine automatically knows that it should search through the gadgets category. It will search through the gadgets category, and then in gadgets category there are different gadgets, then computers, then there are maybe printers, then there is a categories of the phone, then there are different kind of the phone, smartphone, then there are different kind of smartphones, Samsung, LG, iPhone, and then in the iPhone there are different categories, and then it will go to the iPhone X, and then it will take that information and will displays it to you. Now, there are several processes, several things are involved over here. One thing is database, algorithm, and third thing is uh, metadata. What is metadata? What is algorithm? Metadata, you know that last time we discussed data about data is called metadata. So for example, what is the metadata of iPhone X? iPhone X is the smartphone is the metadata. What this mean? iPhone X is a smartphone. This help us to understand, this data will help us to understand iPhone, what iPhone X world. So this is the metadata. Now with this metadata, it goes to the algorithm. Algorithms now will have the ontology. You have to search on internet what is ontology, and you will find it. We will definitely in the next classes we will discuss in detail about ontology. At this time you can find ontology, ontology. What is ontology and the role of ontology in information retrieval? With the metadata and algorithms such as ontology for knowledge management, and with the database, a search engine just like a Google will search your data from the stored databases and will show it to you. Okay, now you please just go and revisit this link, and now you will see the metadata, you will see the databases catalog, and just recall the example of the library which I just gave you in your mind while browsing this page again. Now you will get the idea that how the search engine works in real time. Okay, please write your notes whatever you have. From the end of each slide, pause, you should pause the video and write whatever comes to your mind, whatever you got from this slide. This will prepare your notes and this will help you at the end to revisit your notes, and you do not need to go all these slides. You can just go to your specific slide, and you can just just go over to the material for your exam preparation. Okay, now let's discuss another concept, very important concept, which is interoperability. Interoperability, we will discuss this word several times throughout this course. Now you see interoperability, inter plus operability, or you can say inter mean cross operability or cross portability. How we can define it? We define the ability of the computer system or softwares to exchange and make use of information. Now let me give you an example. Okay, so I give you a flash drive, a thumb drive, with a file name course outline dot PDF. Okay, so this I will give you in a flash drive, okay, and I ask you to open this file and read your course outline on your computer. And on your computer, suppose there is no PDF reader available. There is no PDF reader, Acrobat reader, or any reader which could read the PDF file. You will plug in your this flash drive USB, but you will not able to open this file. If you will open that, you can read that. Similarly, if there is any file with just say there are some songs file with MP3, and you would like to play it on your computer, but if there is no MP3 player is available, then you cannot play the files. Okay, now consider that you have that I gave you a song file .mp3 extension, and you have that mp3 player in your computer, and you click on that and it start playing. This we card, you see this file is generated on my computer but you would able to play on your computer. Similarly, if you have a PDF file, or you see you have a PowerPoint file, and you share that PowerPoint file to me, and as I have the PowerPoint installed in my computer, I would able to see your file. This is called interoperability. So the ability of the computer system or software to exchange or make use of information. So this was the piece of information I would able to exchange, I would able to use that we call the interoperability. But for the interoperability, we just learned that everything must be standardized. What this mean by standard? This is standardized. Like we have to follow some order. We have to follow. We have to use some software. Standardized mean the otherwise computer B will not understand the data transmitted. So the MP3 or the PDF is a format of the data, portable document format. So we have saved our data in PDF format, and if we try to open it in some just like in the Word, Microsoft Word, or in any other softwares, it would not allow us to open, or even if it is open, you will see it's not properly readable over there. What this mean? That this standard in which we have saved the file is different from this from a software which could open another standard. The standard incompatibility. So interoperability is the ability of the computers or softwares to exchange and make use of information. Okay, now please just pause this and write whatever comes to your mind, whatever you got about the interoperability on your paper. Also search interoperability on the Google and look for the syntactic interoperability and semantic interoperability. Look for syntactic interoperability and semantic interoperability. All right, let's move on to the computer architectures. So these 4, 5, 6 slides are very basic. So far what we have learned: information retrieval. What is information retrieval? You should know. This should be, your definition should be very clear to you. Then how the Google search engine works, I gave a couple of examples. The example of a library and library iPhone X uh, will help you to understand. Then interoperability of the computer, sharing of information from one computer to another computer in a standardized format is called interoperability. Now, computer architecture. What comes to your mind when you heard the word architecture? It's more of architecture word used when we use some building architecture, some park architecture, but mainly it's relating to the building, right? Building architectures are design or plan of a system, can be both physical and conceptual, right? So when we talk about the building architecture, it comes to a map or wireframe, that how this building is designed. Where are like a first floor, second floor, third floor, then doors, then windows, then different types of the room. Architectures tell us the overall architecture of the building. Same as in the computer, in the most computers use the same basic mechanism, right? So most of the computers that we have today, They all have a hard drive. They have the memory, which we call RAM, random access memory. They have the CPU. Now they have some GPUs. They have the motherboards. The basic units they have here. So the but how we differentiate between a one architecture computer or between another computer? We say, oh, this computer is a fast, this computer is a slow, this takes more time. So how we differentiate? We basically differentiate one computer with another computer based on their specifications, right? So what I mean by specification mean like the difference in speed, storage, number of possible users it can connect. For example, at your home, when you have the internet, you see like when one person is working, it's blazing fast, but when 2 3 4 people they start joining, you see there is a delay in your internet speed, which means then you say, oh, our internet is slow. So I mean, uh, and when you go to your friend's home and other internet, you see even 4 people 5 people are joined, then the speed remains constant. So here the way we differentiate that, the overall in general, our home's internet is slow comparing to the other. Similar, we say our computer is slow. So basically, we differentiate that based on its characteristics, as some of are mentioned here. Now, types of computer. Types of computers, we have the personal computer, and you see this word PC, we often use PC, personal computer. Normally, the PCs are designed for a single person use, right? And examples of the PCs could be the Mac, Apple Mac is PC2. Normally, the Windows system, Windows is a software. Windows, Mac OS, operating system. These are two softwares. This is you see the hardware part. The hardware part, we generally can call it a both PC, personal computer. These are Windows and Mac OS basically are the two different softwares. These PCs are also known as microcomputers, but you see, we do not use this microcomputer anymore, as this is PC is quite common. Microcomputers people they used to use in 80s, in 1990. So built on a smaller scale than the huge system is used by most business. So at this time, whatever you see in your office, in your home, where they have a one box here, and the CPU, and then we have the screen, we call it the personal computer. Very basic, I know, but as I said, that we have to take with us the people, those who have absolutely no background in computing. Now the desktops. So PCs are also called the desktops, but PCs are the desktops, a PC that is not designed for portability, which means our laptops are not PCs, right? Is not the like desktop computers. So setup computers in a permanent location, usually you see we have in our labs, we have the permanent computers or workstation, we also called workstation, right? Usually offer more storage and versatility than the portable one. You see most of the computers that we have, like the portable one laptops, they are not powerful enough comparing with the computer those who are stationed at some place. Then there are laptops. All we use laptops. The difference between laptops and desktop are like you can take these with you. Portability is the main thing. Now they come with the integrated keyboard, mouse pad, trackpad, and the screens to display the data. Notebook. Notebook are ultra portable computers that are even smaller than the traditional laptop. So are the, you can say the mini version, are the smaller or less powerful version of the uh, laptops. We call it notebook or netbook or notebook. Why we call the netbook? They mostly they don't have the hardware, just like they don't have the storage, they don't have the expensive hard disk inside. Mostly, these netbooks are connected with the internet, and then you store all your information just like on your Google Drive or the OneDrive, and they just provide you the operating system, and they have a uh, very smaller memory, and also they have less powered processors, and that's make it very cheap comparing to the laptops, because they are doing their computing, they are doing their are storing their informations on internet online. Now let's talk about the PDAs. What are the PDAs? PDAs are a personal digital assistant. PDAs are used, but not quite often. You don't see, it. It were you. The PDAs were quite common in 1990 to 2002 3, but after that you see very few people are using the PDAs. Personal digital assistants are tightly integrated computers that often use flash memory instead of hard disk, or and they have the small, either they use stylus or they have this small keyboard to work on, and don't have the keyboard, but rarely on touch screen technology for users. PDA are typically smaller than a paperback novel and very lightweight. Uh, so the people they use just like the pager and a PDA in the pharmacies and hospitals environment in late 90s, and but now you see with the advancement of technology and with the arrival of the smartphone and cheaper phone, PDAs are mostly replaced by the smartphones. Workstations. So desktop, we see the desktop, we see the PCs and workstations. So all three has a common thing is that these computers are stationed somewhere. You cannot take them and on with your bag and can move from one place to another place. Difference between PCs and desktop, we often use interchangeably between PCs and desktop. Workstations are the computers with high processing and with high powerful computers are normally referred to the workstations. There is even in the office environment, people they use PCs versus desktop versus workstations interchangeably. Workstation technically we refers to the is simply desktop computer. They have a more powerful processor, some additional memory, which can handle heavy tasks, just like the some 3D graphics, some 3D videoing. So this kind of the computers or desktops we refer to as workstations. Okay, so the workstations, PDA, netbook, laptops, desktop, personal computer. Please pause and again write on your notes whatever you would like to write about these slides. And after that, you can resume for the remaining lecture. Okay. Servers. Uh, Possibly you have heard this word server. Server, as its name suggests, is a server, a computer that has been optimized to provide service to other computers over the network. Usually have a powerful processor, lot of memory, and large drives. For example, servers we have in our labs, in our office environment, we have the servers, we have the bigger computers that have more memory, that have more processing. And here we have our small computer or desktop computer. Whenever we would like to store some information which we cannot store in our computer, like as we have some limitation of the memory or storage, we can store this information on our server as a secure place. Or if we want to do any computing tasks, we can use our server over here. We all use Google Drive. So Google Drive, they have their server. They have their server with powerful hard disks, very, very heavy, just like hundreds of terabytes. And we store our data to Google and retrieve that. And we have the peace of mind. The data is stored and it's automatically, they take the backups. And so as long as we remember our password, we can retrieve that data from anywhere, uh, from anywhere. So that's the beauty of using the server in computing environment, right? Now, mainframes. What are the mainframes? So mainframe is almost now an obsolete concept, but in early days of computing, mainframes were huge computers that could fill entire room and even a floor. Right at the time of the Apollo, uh, and you know, at the earlier age of the scientific discovery, they used to use a bigger one computer with a which takes the entire room, and now referred to as enterprise server. uh, Basically these are the set of servers. There are, see, one server, two server, three server, four server, five server, and and could be several hundred server, and then they integrate them and they refer to them the mainframe computers. They have a several display, could have several display. If you see a rocket launch, you see, like, you know, one bigger screen, and there are several small screen next to that. So basically they are using the one mainframe or one supercomputer to that. Now mainframe is we generally refer to as the with the supercomputers. Just like, you know, the example of the supercomputers we use for, like, just like a Mars mission, we use that for missile tests, we use for, you know, kind of heavy computing, just like to predict the weather. We all use supercomputers. Basically these are the computers which are very, very costly, millions of dollars, even some billions of dollars, and they are used to do the tasks which require a high processing, and can do the things in very, very fast and short span of time, and we refer to them as supercomputers. So here I have list a couple of supercomputers. You see supercomputer Summit, Sierra, Sunway, and so you can, if you can go to the Google, Wikipedia, and search supercomputers, it can tell you it can give you the list like this. So every few months, whenever, so this list is keep updating. They keep updating that based on, you know, you see here different flags even. So now this is a race of like the computing with the different countries. You see the China, you see the USA, you see the different countries competing every year in supercomputing, and so you will find the list of the supercomputers here on Wikipedia, or even you search, maybe you can find a video on YouTube. Okay, so far we have discussed couple of different examples of the hardware. in the computers, laptop, PDAs, servers, mainframe. Now let's look at computer softwares. Maybe you have heard the word computer softwares, and we all use the computer softwares, but probably you don't have the proper idea about the hardware computer software definition. So let's see what is computer software. All functions performed by hardware of a computer systems are directed to the by computer programs or the softwares. Basically, as I said earlier, so this is a hardware piece. This is a hardware piece, and operating system. This is a software. Microsoft Word is a software. PDF reader is a software. Anything which is not tangible, which is not hardware, we can and it helps to run computers programs, we call to softwares. And at this time we are using for different purposes, right? From data acquisition, from wherever we like to use data, we can use for the computation. We use computers for multiple purposes. Like you see this, the use of it could be in a hospital setup, it could be in pharmacy, it could be in scientific biomedical research. So we use computer softwares for different purposes. No computer languages. Uh, so you see how we interact with the computer. You see this is a piece of hardware, then this is a softwares. We input something into the softwares, then how this software communicate with the different pieces of the hardware and can return. For example, when we say 2 plus 2, how the computer first know what is 2, and then what is plus, and then what is this. So basically these are some mediators, we call them computer languages. So these languages translate whatever we write in a high level language. Computer is a hardware and an electronic piece of equipment, and it just understands 0101 in binary, right? Whatever we will give the input, it convert into a byte code 010101, and then this 0101, the processor will understand this, and then whatever the function, just like we have the plus minus arithmetic function or and any other instructions, it translates that into a binary code, and after computing that it will return us the result. Again, this binary is converted into a high level language. So you see this, we have the hardware, at the hardware, right? Then we have the, here we are at the high level, here we have at the high level, right? So we use some languages, like we use Fortran, we use C, we use Pascal, we use Java, any language to communicate with the computers. And these languages are called high level languages. Then these computer will convert that into assembly language, right? Assembly language is one level higher than this binary language, but this language we cannot understand that. This is very difficult to understand for a human, because it's a mix of 01 with some symbols, with some characters, and then it will convert into 0101, and then it will communicate with the hardware, and then they return back from the hardware to the machine language, to assembly language to hardware, high level language, and then we would able to understand that. So this is go from top to bottom and bottom to top when we would like to communicate with computer systems. Now recall the last week, and the last week we discussed about data, information, knowledge, wisdom, So let's see now data management and its relations with the healthcare. So data provides the infrastructure for recording and information sharing, right? So we have some data. When we add another data, that becomes some information. And then this information we will use from some decision making. So data provides the infrastructure for recording and information sharing. Data becomes information when they are organized to effect decision, action, and learning. And based on this information, we can assessing and moving data from one point to another. So we will basically take some decisions. Okay. All right. Database management system. What is database management system? Anyone has any idea? Please stop this video and write database management system, whatever comes to your mind on your paper, and then resume this video and compare what I will teach you with what you have write on your paper. Database management system. Database technology support the integration or organization of data, assist use data entry, long-term storage and retrieval. Before even going to this definition, let me give you a simple example. You see, data and base, we called military base, a station where the military people they live over there. Then we say database, a place where we will hold our data, right? So a computer place where we will store our data is called database. But we cannot just randomly hold the information. Why? Because we would like to retrieve the information, we would like to update the information, we would like to delete or change the information. So in a database, we not only store data, but we store the data in a way which is very organized, right? So another example, I guess everyone is familiar with the Excel sheet. So we store the data in a tabular format. So they have some headings and there are some data, and this is the one way of storing the data. And if you have familiar with SQL, and maybe some are familiar with Oracle, so these are all the databases in which are used to store the data. And what are these called? So these field, these are called, this is called columns. This is column and this is row, and this box is called data field or data element, right? So the meaning of data element and the relationship among these elements captured by the structure of the database. Now, for example, we have a patient database, right? So we have a patient database. There we have a table patient, a table patient. So we store the data in tabular format. So see, we have ID, name, gender, then we have say a city. So here we say one name is Chris, gender is a male, city is New York. So this is this called data element. So Chris is one data element, new NYC is data element. So to remember that, the place where we will store the data in an organized way, we call it a database in computer system. And in a database, we normally store the data in a tabular format in a row and columns fashion. And on top of the columns, we have the identification of the columns, and then we have some data element in the table. Some examples listed here. Now, the word fields. So basically, there are several concepts over here. This is called, let me take another color. Okay, so this column, right? This called row. This also we call it record, and we also call it technically tuple, T-U-P-L-E, tuple, right? And this is called this called is a record as well, the individual records, right? So the columns fields are usually grouped together to form a record. So basically this is a field, this is also called a field, one field, field. A record is uniquely identified by one or more key fields, patient identifications, and records that contain similar information are grouped together. So basically, this is the information about the patient. So we group together and we call it a tabular patient table. In addition to files about the patients and their diagnosis, treatment, drugs, therapy, the database of a healthcare information system will have a separate files containing information about the charge and payment. So if you see in a healthcare setting, in a healthcare environment, we will have several tables that are interlinked with each other. For example, we have tables about the patient, we have the table about diagnosis, we have the table about the treatment, we have the tables about the therapies, and with all they make a database. So what I mean, so we have table about patient table, then we have the table about the diagnosis, then we have the table about the treatment, then we have the table about the drugs. So when these tables are combined, these called database. Okay. Now, what the database offers to us? A database, now the database management system. Database versus database management system. Database, we know that a database, a place where we store the data. Now, database management system is a software which runs the database. So database, consider database is equal to a song, MP3 song, right? Just give you an example, or the file. And we run this song with .mp3 in some MP3 player, right? Similarly, a database which we just have created will be a file. We must have to open this file in some software. That software we called database management system. Okay. So again, the difference between database and database management system: database is a place where we store data, and database management system is a software which plays or which runs the database. A database management system, when we say it runs that, what does this mean? It means it helps us to to do multiple functions with the database. For example, we can enter some information into database, we can edit some information, we can retrieve some information. So what you will do that basically, just consider the examples of the UIS, or consider the example of the canvas. On your side, you will see every day, on every week, professors upload the lectures, upload some class assignments, and student would able to see that. And on my side, I have a view where I can upload that. On your side, when you would like to submit your assignment, you will see an upload option or button. So everything is going to be stored at a centralized database, right? Everything is going to store at a centralized database, and I have access to that database. You guys have access to database, and admin, university management also have to the database access. Now what we can do, that we can update database, we can delete database, we can do different functions with the database, and that functions we can do that with the help of the database management system. To run that database management system, we use a language, right? That language, probably if you have any computer science background, you or any IT background, you have heard about the word SQL, structured query language. So this is syntax, is the structured query language syntax. Now what these are doing? So we use different keywords, just like the select. So we are saying to the system, select patient ID, patient name, patient age, and also patient systolic record. From where? From the patient table, from the patient table in the database. But then we are saying, we show us the patient where they have the sex male, and their age is greater than equal to 45 and less than equal to 64. Also their systolic is greater than the 140, and then it will, based on these filters, it will give us the list of the patients. Now you see that how this language help us to filter down the our search. So we usually don't see this kind of as an end user, we don't see this kind of a language, but at the back end we work this language. For example, you go to the Amazon, you find a product, you would like to see the product which have a high ratings, you would like to see also high rating but cheaper than $50. And so all these filters you apply, basically this kind of the query is being generated at the back end, and then the system will run this query and you will see the results. All right. Now let's move on to software development and engineering part. In this part of software development and engineering, we will mainly discuss the software development lifecycle. So when we say software development and engineering, so you see why we need a software development and engineering. Developing a piece of software is not that simple. It has a multiple phases to develop a software, and softwares are often complex. Software offer resource intensive undertaking. Multiple people are working different environment, especially in the healthcare settings. We have additional requirements. We have the about the safety security of the information. We particularly take care about the privacy of the patient data and hacking issue. So other than that, the softwares that we can use for just for the general purpose softwares, just for the pizza delivery, or to keep the records of some books, a patient or healthcare setting softwares require much more security, and that's why we divide the whole process into a development process. And idea is that uh, that how we can develop an efficient softwares with a less time period, with using less resource, less energy, less money. And that's why we use software development life cycle. Okay. Let's look at the software development life cycle. What comes in a software development life cycle? So it starts with the requirement analysis part, right? We will see in detail what is in requirement analysis. Then we'll look design part, implementation part, testing part, and the evolution or evaluation part. So for example, we would like to build a software for a pharmacy. uh, a person, Adam, came to me and said, I would like to open a pharmacy here, but to manage the pharmacy inventory, I would like to have a software in place. And as a developer, he asked me, could you please help me with that in development? Uh, I see, okay, we can develop, we have the team, but we will follow a process called SDLC. And he said, okay, what's the SDLC? So then I will explain to Adam. In the SDLC, we'll start the process with requirement analysis. Okay, so let's see what is in requirement analysis. Requirement analysis or the planning part. Here we define the formation of project goal. Why we are developing this? We will write this. We will write on a piece of paper why. What's the purpose of this softwares? Uh, we will focus on particular outcome. What we would like to achieve from these softwares. What would be the particular function? Uh, then I will ask to Adam, do you have any idea, any concept how you would like, how you envision your pharmacy softwares? And also define initial scope of the project, like what functionality you want. You just want the all the drugs name into it, you just want to search, or you want to kind of link it to a doctor office. What do you want actually? uh, so we'll try to get all possible requirement at the planning phase and write on the piece of papers or through the on the digital something on we have a special software for that, but you can use it. You can start from a piece of paper. After that, uh, then we go to the design, and design is not we directly hit to implementing and coding that. We potential software solutions are explored. We see is there any similar kind of softwares are available, and if they are available, what kind of the architectures they have, and how it would be the similar or how it would be the different from the requirement which are explained by our project investor. And then we'll see such as a security issue, performance issue. Maybe the people they would like to have internalizations, like other than the English language, maybe they like some Spanish version of that, some user requirement. And at the end, we will start some mock-up designing. We don't directly hit towards a full-fledged version. We just design a small component, show it to the owner, show it to the real people, those who would like to use by the end, and then treat that, add some changes, show them again, and then this process will go on with the design phase. And when the people are almost satisfied with that, then we hit towards the development part. And at the development part, coding of the software is done during this phase. Use the requirement and system design. And basically here, we will use the high level languages like the Java, C++. We will use backend Java databases just like SQL, Oracle. Then we use even make the system web-based system. We develop some desktop-based system. So everything according to the requirement, according to the agreed kind of the requirement, we try to implement at this phase. When we are done with the development part, we go and hit with the integration. So usually, big softwares have a multiple part, and one team, 4 or 5 people are working on one part, 4 or 5 people are working and other part. And at the end, what we would like to do, that we would like to integrate a different part of the software. And with at the integration process, uh, when we are done with the integration, we will go uh, towards the testing with the real requirement. We ask to the people for the test with the real use case, and if they are satisfied with that, then we go towards the implementation or deployment of the softwares. We install the softwares, we test with real hardware, we offer people for the training, and we see whether there are an issue. We monitor the issue. We ask also the people to record is there any kind of the bugs on error, so that we can fix them later on in the verification and the validation part. So this part, we ensure the software satisfy all the user requirement. And if the some we see that if there are components or some additional component, these components are not very usable. And so we based on the data that we get, with the survey that we get, we keep changing the softwares until the users are satisfied with the with the process. And then operation and maintenance, this is considered to be last stage when the softwares are deployed. But you know that as we move on, like from the every year there are some new requirement comes, and some functions which we previously was using, we no need no longer needs to those functions. We try to obsolete or discard those functions and try to upgrade and update with the functions which are new functions. And so the steps for the operation and maintenance is a continuous process. And evaluation, organization might perform some formative evaluations during each phase depending on the specific need in order to assess the input. So the evaluation evolution evaluation process goes with the evolution process. As we move on, we see different errors before even when you deploy the softwares. Different people work on that with different kind of scenarios to look at that the software's activity or behavior, to check that whether the software is working up to their standards, up to their requirement, and if not, they ask for the changes. So with the help of the SDLC process, software development process, it helps us to systematically develop a system, from the requirement analysis to design to implement to test and to the valuation plus the evolution. So software development life cycle, please write on your paper what you will get about each of these phases as for your notes. Now, warehousing. What is warehouse? Warehouse is just like, in a warehouse we see a Costco warehouse, we see the other warehouse. In the warehouse we do not have maybe just one kind of the items. We have a multiple kind of information. So just like we see in a database, we have a table, patient table, drugs table, and diagnostic table, database one. Similarly, in a warehouse, we have a multiple databases, database one, database two, database three. Uh, so the database about the patient, here we have a database about hospital. This is the database about the hospital one. This is database about the hospital two. This is database about the hospital three. So clinical data warehouse can be used to evaluate critical clinical process, cost estimation, and can analyze the potential solution. If we would like to see in the New York hospital what is the most common disease at this time, we cannot get this information just from one database. We have to combine multiple databases and to get the knowledge information from multiple sources to suggest that like what is the common disease at this time. That's why clinical data warehouses are highly valuable in informatics because it helps us to take some data-driven solution. So clinical data warehouse can help us to track infection, report trends, and public health. So everyone, all the hospitals are reporting their data about their infections, their data about the COVID patient, their injuries data, and all the data are stored into centralized data. For example, this is database of hospital one, this is database of hospital two, hospital three. So all databases go into, here they are logically linking and into go into clinical data warehouse. And with this softwares, we can see the overall view. We can query with the help of the SQL from all the hospitals. And this is how the data warehouse will help us to see the data coming from a different hospitals, and it could provide us the overall picture, or can give us the information that could help us to take decisions more uh, uh, like uh, uh, more wisely. Okay. Now, in the last 2 weeks, we discuss some issues which where we see these there are some known issues which can make the biomedical healthcare informatics difficult. One of the issue is that, the it is very difficult to model all healthcare. Healthcare is so wide, it's so big that we cannot model all the healthcare. We cannot model everything in pharmacy. We cannot model what they have here in a clinical setups. Not so biomedical information is difficult to incomplete, imprecise. A second thing is biomedical concepts are really fuzzy. For example, a high fever. What is high? The computer does not understand high. Computer understand 102 Fahrenheit, 103. So we understand high, low. These are the very fuzzy concept, like the pain, severe pain. What is the severe pain to the computers? Computer does not understand. For us, we have to give some number. We have to give some. So these are some challenges involved. Which are makes the really difficult. And another thing is like the adaptability issue. As we discussed, the people are really reluctant. Hospitals are have to spend a lot of money to train their staff, and even the staffs are they are busy in their jobs. They have to go to learn a new software. They have to spend some more time other than their job. So this could also make the implementation or adaptability of healthcare informatics difficult. And there are some other issues. For example, health IT is an attractive solution to our troubled healthcare system, but is it realistic? I mean, how feasible that every hospital will implement that? Every hospital is not have a that money or that resources. So other IT fields have experienced serious ups and downs, such as artificial intelligence. And now the serious question on artificial intelligence: should we rely on artificial intelligence system in clinical decision support system? And there is also large gap between healthcare data generation and information. And is it too early to expect EHR and computerization to change healthcare? So basically, these are the questions for you as well. The working in healthcare system, to answer those, think about that. So where we stand at this time. So in summary, I would say the computer scientists focus on data, while informaticians focus on information, right? And information retrieval, we have the information informatics circle, computer circle, and information retrieval. And then we say there is a gap between healthcare data and information. We call this a semantic gap. We see the interoperability, and then we say I said search on the semantic interoperability and the syntactic interoperability. I will create a discussion about on this. Please check that. That would be a graded discussion in your week as a homework. Then we learned about the transformation of information into knowledge is a primary goal of informaticians. We get data and we go from data to information and from information to knowledge and decision making. So here it will come the role of the informatics. And when it comes to the health data to health decisions, then not ordinary informaticians can help on this. There are some terminologies, tools which are very healthcare related, and only healthcare informatics person would work on that. Then lastly, clinical data warehouse are increasing used to reach clinical questions to generate information. So that's all from this lesson. Please go over, read chapter 2, and also look over to your homework. And if you have any question, please post on Piazza, and I will see you all in the next week. Thank you so much.